the point is, if someone's younger or someone's changing careers, jump on this wave, right?
There's no downside as far as I can tell, right? Because normally you might imagine there's a downside where like, what if this technology goes kaput? With AI, I think we can kind of rule out the idea that it's going away.
Yeah.
Right? Because it just keeps getting better, and also it solves so many problems. Even if it didn't get better, it's still super useful for solving problems as part of other pipelines and things like this. An understanding of AI that you get in 2024 is going to last you a lifetime, because I just can't see how it would go away. It will look very different in a few years, but you'll be able to build on that knowledge that you've already got. So I think there's no drawbacks. Outside of the core of the hype stuff that you see in the media, there are thousands of examples of smaller AI and deep learning applications that are solving problems across the world. And they just quietly happen behind the scenes. They don't, get all the big hype, but they're doing a huge transformative job. And so even if you don't go and work for the big tech company training the next ChatGPT, you might still be doing something with massive impact, right? And really, really worthwhile doing. I think that the roadmap, right, for AI is...
Hey everyone, it's David Bombal back with the amazing Dr. Mike Pound. Mike, welcome.
Thanks for having me back.
It's great to have you. You're the person I always talk to about AI, how it's changing our lives, the hype, the reality. What I really love about what you do is you tell us not to fall for the hype, and you tell us what's actually going on. So what's the state of AI, or, where do you see it where it is in 2024?
Yeah, I mean, it continues to move really, really quickly. I think that there's still a huge amount of hype, so we can talk about that. I'm not going to change my tune on that front. I think the thing that we've seen change really quickly is more image generation stuff. So yes, we can still talk to AI chatbots and we can still have good conversations, but now we're linking in images. So now we can produce images, it can describe images. We can say, remove this thing from the image and put in something else instead. And these images are just getting better and better. So, we're fully into the area now where, you can't absolutely be sure that an image is real or fake now. Not always anyway.
I've seen a lot of YouTubers use it really well for generating thumbnails, and I've been using it as well. It's amazing what it can do. Exactly like you said, just tell it like with a quick sentence. My daughter's been playing around with it, like create a hacker cat or whatever, a cute hacker cat, and then it creates this thing. But I mean, like you said, some of it's so realistic, you have to look really carefully to see what's real and what's fake.
Yeah, and there's going to be obviously a lot of regulatory problems with that, because, we're going to have a situation, maybe not tomorrow, but sometime where there's an image in a court and someone's trying to decide if it's real because it's really important for some case, right? And this hasn't happened yet, but it's not far off.
There's the famous example of Tom Cruise being an actor pretending to be him and putting out TikToks or something. And, you have to look carefully.
You do. And actually, I made a joke on one of my videos that, I don't look enough like Tom Cruise for this to work. And then the next day on Twitter, there was a video of me with the face of Tom Cruise just talking in my voice, and it was pretty good, right? The speed at which you can produce these things now is quite incredible.
I think I want to talk about like opportunities, because that's a big thing that people are interested in, and also like the worries, because I think people are worried that the jobs are going to be taken away. There's this concern that, in the old days, technology was taking away perhaps factory jobs or basic jobs, and AI is going to take away a lot of like knowledge worker jobs.
I mean, at the moment, I don't think it is, in a sense that I think these AI tools are really impressive. But of course, when you actually really start putting pressure on them in terms of something really difficult, they start to fall down a little bit. So I think that, your job's safe for now. But, inevitably, eventually, we are going to have, image generation that's so good that, it is comparable to an artist. We're going to have text generation that's so good that it's comparable to a writer. I think as a society, we have to think about what we're going to do when that is the case. Now, there are huge other concerns like, who owns the writing that an AI has produced? Maybe it's the people that trained it, right? Or maybe it's the text that went in to train it. So there's a lot of unanswered questions. I think in the short term, there's not a huge threat to sort of office work and things like this. If your day-to-day job is, coding, or your day-to-day job is data entry, or, financial work with, let's say, spreadsheets or something like this, the ability of an AI to use these tools is still limited, right? It's impressive sometimes, but it is limited.
I've had feedback from people that it's great, for instance, to help with boilerplate, and I think you said exactly the same thing. Boilerplate code, it's great for doing certain things, but in our previous video, you mentioned the fact or the problem that it could write code that has vulnerabilities in it.
Yeah, so, we don't know because we haven't been told what all this data has been trained on, what these networks have been trained on. So, there's going to be correct code that it's trained on. There's also going to be bugs in the code that it's trained on. And we don't know to what extent it will overcome these bugs, or they'll come out in the wash, or whether it will just repeat these bugs back to you when you use them. I know a lot of people who work for companies who have policies in place about the use of these tools, just from a safety point of view more than anything else, right? If you've not got a sort of a set of human eyes on something, at the moment, we're not in a position where we can fully trust what we're getting out. And so, if you're writing code for a living, by all means use these tools to help you speed up. If that works for you, that's great. But I think that the idea that you're going to be able to go home and just let it churn away on its own, we're not quite there.
But it won't, and that won't be coming for a while. I've heard people say that artificial general intelligence is also a long way out. We might not even see it in our lifetimes.
Yeah, I think that will be broadly what I believe. AGI is a term that's used far too much in the modern conversation. I think because it's exciting sounding and it has, sci-fi, implications and stuff like this. But I think realistically, the majority of researchers think that, in the next 5 or 10 years, we're just going to see better versions of what we have now, but nothing's going to substantially, completely change in terms of, we're not going to jump from where we are now to something that can, think and act for itself. We'll see if I'm proved wrong, but I'm pretty firmly a believer in that. So I think that we're just going to see much better chatbots and much better image generation. One thing that hopefully we'll see soon is more grounding in real data. So, when you can see this on Bing already. If you use Bing, it does a kind of web search and then injects that into its own prompt to try and give you better informed information. Now that sometimes works, it sometimes doesn't. But I think that grounding the output is a good idea, because at the moment you're just getting a kind of amalgamation of training data which might be out of date. Right, or it could be incorrect.
Correct me if I'm wrong, but I see that the industry's kind of moved on a bit since we spoke as well. I think last time we spoke about 2023 outlook, and it's good. It's interesting to see what's happening now in 2024. In the old days, you had to get like a PhD. I had to be like you if I wanted to use AI. But these days, I can use APIs. So it's like we've got the users using like the front end on ChatGPT. That's one opportunity perhaps to create thumbnails. And then you've got like the developers who could use the APIs. And then you've got like the hardcore stats guys, math guys, people with PhDs like yourself. It seems like there's like 3 groups now, and there's a lot of opportunities in each of those.
There's opportunities everywhere. Yes, you're absolutely right. So if you take, one of the terms that gets used a lot is these kind of foundation models, which is a model that is incredibly large. It's been trained basically by resources that most people don't have access to, so big tech companies. And you can deploy these models on subtasks without too much expertise, right? So for a good example is the segment anything model, is a model where you point it at an image and it will just start picking out objects. Now, actually segmenting objects for many years has been a really difficult problem, but you can use this as part of your pipeline. You don't really have to know how the AI works to be able to use this tool. It's just run it in Python. It produces you some objects, and then you can decide which of those objects you want. Let's suppose you're writing a web app that, let's say picks people out of an image. You can use the segment anything model and then just tell it to find people, and it'll go off and do that. And you don't have to know how the network actually segments the people. Yeah. You're just using the polygons that come out.
So in other words, there's a huge opportunity now where it's open to a wider community of people who perhaps are not hardcore AI guys, but they can leverage the power of AI just by interfacing with the APIs.
Yeah. So these companies are exposing these models via APIs that you can then, you can make use of. And, we see a lot of companies doing this. Many of these tech startups are essentially a wrapper around, let's say, ChatGPT's API and trying to use it in a clever way. To an extent, there are risks doing this because, of course, you don't know exactly you don't control ChatGPT. You don't know how long it'll be online for, and these kind of things. But on the other hand, it gives you access to models that you couldn't otherwise have trained and you couldn't otherwise have actually done yourself, because maybe you didn't have the expertise, you didn't have the resources. And so I think that it is lowering the barrier to entry for a lot of people.
Yeah, so rather than me trying to get like crazy data sets, because that seems to be the biggest problem, right? Getting the data and then like the GPUs and all the power to run this. And obviously the expertise like yourself, I can just leverage an API and I've got it.
Yeah, it's difficult to overstate the number of resources needed to train ChatGPT, right? First of all, you need massive amounts of internet data in the order of trillions probably of tokens, right? At the very least, high numbers of billions. And then, so that in itself is a data nightmare. But then you've also got, the hundreds or thousands of of GPUs across hundreds of machines that train the model in a distributed fashion, all the infrastructure to do with this. No need to do all that, just sign up, get your API token and off you go, right? And then you can talk to this thing and you can tell it what to do.
I'm interested in this. Do you have recommendations, for instance, of languages I need to learn, perhaps books? How do I get started? Because AI is so much hype in the news, but how do I practically use this to, for instance, have a business or just change my life, in some ways?
I think that actually one of the things is what you want to do is educate yourself to an extent where you can get around this hype, right? Because that will allow you not to be taken in by the most flashy tool, but the one that's going to work best for your use case, right? And so I think to do that, you need a little bit of expertise in certain areas. You don't need to do a PhD. By all means, come and do a PhD with me. That would be fun. But, if you haven't got the time to do that and you want to get in on AI more quickly, then sure, there's lots of things we can do. The first thing is, you don't need a tremendous amount of mathematical knowledge. To run AI, you definitely don't need much mathematical knowledge at all. You can even train networks without much mathematical knowledge. If you want to read the papers and understand the networks, you might need to know a little bit of linear algebra and things like this, right? But that's about the extent of it. You can get away with a little bit less. I don't mind maths. I use it when I have to. I avoid it also quite a lot of the time. So, it's not so bad. The primary entry point is going to be learning Python. That's the main thing you need to do. For whatever reason, I've said this before, I have a love-hate relationship with Python. Some days it's my best friend, some days I can't stand it. But ultimately, this is what the AI community has settled on. If you're going to use machine learning, Python is going to be the thing that runs your networks. Python is going to be the things that handles the input and the output of those networks. Now, of course, they're all actually implemented in C for speed and CUDA on the graphics card, but you interface with them using Python. So that's the first place to get started.
And do you have any courses, or do I need to? It's just basic Python. Just grab some how to get started with Python.
Yeah,
or do
actually,
you have stuff?
It is really. I think any appropriate introduction to Python course is going to be fine, because what we're doing in Python is not actually the most complicated things that Python can do. Right? If you're writing enterprise level software, you might not be using Python, but if you were, you'd be using a lot of perhaps more sort of advanced stuff around the edges that you don't need to use to do machine learning at all. The main thing, you need to know how the data structures work, so lists, dictionaries, and then pretty quickly, once you've got a grasp of the fundamentals, you can actually start training up smaller networks to get your head around the quirks of each particular library. So for example, PyTorch has a data structure that it uses called a tensor. In fact, actually most AI libraries do, but the tensor is kind of fundamental to how Python and PyTorch works. So the sooner you get going on that and the sooner you play around with these things, you pick them up pretty quickly.
So start with Python, just like a generic Python course, understand lists, dictionaries, basic Python knowledge. Then look at PyTorch. Do I need to understand concepts like supervised, unsupervised learning, all this kind of AI terminology?
What I would say, so, to begin with, not necessarily, right? But what I would say is probably there is a nice progression, actually. Supervised learning is perhaps in some sense the simplest and the easiest to get your head around, mostly because actually still the majority of AI that we see, both in industry and in research, is supervised. It's supervised because that's the easiest one, right? You've got some data, you want it to perform that task, so you just throw the data in and you train it, and then we go from there. If you download code off, let's say GitHub, that has a neural network in it and it trains up something on some task, the chances are you'll be able to plug your data in and go. And you'll have to fiddle around with the data loaders a little bit, in a bit of Python there, but really that's the first thing you can do. Once you've done something like supervised learning, then you can move on to more complicated topics like unsupervised learning, weakly supervised. There's hundreds of subsets of different configurations that you could train with. And then, you could also start to familiarize yourself with these, large language models and these big networks that are trained using a hybrid of different approaches.
Where do I learn PyTorch? Is there GitHub places where I can go?
Yeah, so there's loads of courses, but actually the PyTorch GitHub, the examples and the PyTorch tutorials, those are actually really good resources. There's a couple of tutorials at the beginning of the PyTorch tutorial set, which is sort of things like tensors, auto differentiation, so it's AutoGrad framework. It's worth working through these because you'll just get a feel for what's going on under the hood. So actually PyTorch does a lot of stuff behind the scenes that you don't see. And if you kind of skip over that, you'll get it running fine, but you might not necessarily understand what's going on. But I think if you have in the back of your mind what it's doing, it actually does make it quite a bit easier to use.
So just for everyone who's watching, I've linked a video below. Mike did a great example showing us how to use code that he's used or created and how to like work with images and do some interesting stuff. So I've linked that video below if you want to learn. I'll also put links to PyTorch below. So if you want to learn that. What about last time you recommended, like Andrew has got a course on Coursera that teaches the basics of, should I do that?
Yeah, so I think that, so Coursera, I think, costs more than it used to, right? So that's a choice that people have to make.
I think you can do it for free still, can't you?
I think you can, at least briefly, right, if you're quick. Yeah, I think I still do recommend that course. I think that course is, there's two courses really. There's the machine learning one and there's the deep learning specialization. Now, actually, I'm a big proponent of I recommend often doing the initial introduction to machine learning course because I think it teaches more of the fundamentals that you can't pick up through just having a go. Things like what does the learning rate do and what effect does it have on the training of a network? And what happens if your network doesn't train? What do you do in that situation? Going from machine learning to deep learning is actually not that big a leap at all, right? They're very similar concepts. They're trained in much the same way. It's those initial machine learning concepts that are going to take a little bit of time to get your head around. So that's a good course. There are plenty of courses on all of the online learning platforms in similar things. But I certainly think if you're taking a course that's talking about learning rates, how to train, the training process, how you prepare data, those are the kind of things that are really worth learning.
I think we need to convince you to create a course.
Yeah, I mean, when I find some time, I'll have a go. I sometimes do think about that. Yeah, I think it would be quite good because I spend a lot of time teaching these topics to a lot of people. It would be easy if I'd have just pre-recorded myself. I could just say, go over and watch that and then come and talk to me afterwards.
That'd be great. Yeah, we're going to, so everyone please vote below, put your comments below if you want Mike to create a Udemy course or some kind of online course where we can all learn from him. Now, I really appreciate you sharing this, Mike, and it's overwhelming and you've been doing this for a long time. And like I said, you separate like all the hype from actually what's reality. So
for what it's worth, it's overwhelming to people working in AI as well, right? Because there's so many papers. I mean, we just submitted a paper to a conference where I think submission about 12,000. I mean, that 10 years ago, there were not that many papers in computer vision almost across the world in a whole year. And we're talking now about one conference. The amount of, and the speed at which all this stuff is happening. And sometimes, sometimes papers are small improvements and incremental improvements and are not changing any, much. But sometimes, there's big things coming around. In graphics, we've got these new static Gaussians, we've got neural radiance fields. These things didn't exist a couple of years ago. And now we have to learn what they are as well, And so it is overwhelming, but I think also it can be exciting, right? If you're willing to delve in and read some of these things, there's loads of resources to explain all of these topics. You don't have to necessarily read the maths in the original paper if you don't want to.
I think it's like when there's a shift in technology, it opens up a lot of opportunities for anyone who's willing to jump in, right?
Yeah, absolutely. I mean, I think it's like, when Web 2 came along, right, it was the same kind of idea. I think there is a lot of opportunity. And actually, I know plenty of people who are working in AI who don't have, a PhD in AI. They just got sufficient amount of base level knowledge that they could get in on the ground floor and work their way up. And then, you learn these things as you go as well. Most of what I've learned about artificial intelligence, I've learned by doing it, in my research, rather than just reading tutorials and things like that. So I think you get yourself that base level of knowledge and then pretty quickly you're ready to go and you can start training things and you will learn quickly if you just, keep training these models.
Do you think there's going to be a shift towards like domain-specific AIs where it's like an AI for cybersecurity, an AI for networking, an AI for XYZ technology?
I think that, in a way, I hope there will be actually, because I think that the things like ChatGPT and these large language models, they're very interesting and they're very fun. But actually, I find them quite hard to apply to my own research because my own research is kind of specific. Right? I'm often looking at a medical image and trying to work out what shape that thing is. And ChatGPT doesn't know because it's never looked at that kind of thing before. And so actually, it's much easier for me simply to just train my own thing to do it, right, and ignore the large language model. I think that foundational models or big models trained in specific areas, such as Segment Anything, they're more tailored to a specific task. They're slightly less catch-all, and that means you might have a chance of being able to control them in a way that's helpful to you. So I hope it goes that way. At the moment, I have fun playing with these tools, but for the majority of the time, I don't use them because I've got my own models that I've trained up.
Mike, what's Segment Anything? Segment
Anything is a really interesting, should we say, foundational or large model that's been released by Meta. It's kind of transformative in the segmentation space. Segmentation prior to that has always been a supervised task. That is, you basically, pretty much. So you give it a bunch of labeled regions in a load of images, and it learns to label those regions back. So you might use it, for example, for labeling, products as you're walking around a shop or something like this. Now, Segment Anything is a tool that just segments all the things it can see in a scene and gives them labels as to what it thinks they are. But you can also prime it with points or boxes or text to say, I want you to find all the footballs, or I want you to find all of the laptops, and it will go off and segment them for you. Now, it's not perfect because it's a very general model. It may underperform a very, very specific model trained on a very specific task. But of course, you didn't have to train it, did you? You just run the thing and it's done it all for you. So I've already started seeing papers that are using Segment Anything as part of their pipeline. Right? They build in, just segment everything first, get rid of the things we don't want, and then we've got some useful data already and we haven't trained anything at all.
So it's with images, right? It can pull stuff out of an image.
Yeah. You can think of it, yes, it's a bit like a kind of reverse Stable Diffusion or DALL-E, right? Instead of producing an image, it's taking an image and finding interesting information from it. So one of the tasks that people do is image to text. So they try and describe what's in an image. This is image to object. So it's trying to find everything in an image for us.
But like in your specific use case with like medical data, at the end of the day, it's better to use your own AI because it's that specific domain of knowledge, if you like, right?
Yeah, I think at the moment it probably is. Also, we have the expertise to run it, so we might as well use our own technique. I think in the long term, certainly for outdoor scenes, for sort of scenes you see typically in day-to-day life, outdoor and indoor normal photographs, I think that it will work pretty well. And it might not find everything, but it will find everything pretty quickly for you. For medical images or super specific data sets, you might find you have to train your own specific AI. But what you could do, for example, is you could use something like Segment Anything or a less powerful, a network that gets you the gist of what's going on to start that annotation process for you. So actually it can be used sort of with you in the loop to get data really, really quickly.
So from a jobs point of view, or like, I'm just trying to think, how can I use AI to put me in a different league, like job-wise or, just in general use?
Loads and loads of companies are using AI right now.
Yeah.
Some of them are going to be working on financial data. Some of them are going to be working on networking and security data. Some of them are going to be working on image data. It will depend on the company. Going to be dozens of job types under that umbrella term. So there'll be people actually engineering the networks themselves. There may not be anyone in a company that does that because they may be using off-the-shelf networks. And then there are going to be people who are interested in the data and the storing of the data and moving the data around your site. And then there are people controlling the cluster and the GPUs and training the data. And there are people who are providing a web interface on the front of the data. So, front of the network. So I think whatever your expertise is, there's a place in that pipeline for you, right? And, if you have some understanding of AI, that's going to make it a lot easier because ultimately that's what's actually running under the hood.
So Andrew's course, I think, is an absolute recommendation for anyone who's technical in any capacity, right? Because it gives you good understanding, and then you can take that knowledge.
Yeah, no, that's absolutely right. If you want to learn how to run a model, then what you do is you learn Python, and then you can just basically start running some tutorials, and you can run a model. But you won't necessarily understand exactly what it does.
Yeah.
Now, it might be that your job doesn't necessarily require that you understand exactly what it does. But I suppose what I would say is at some point it's not going to work, right? At some point you're going to train it up and it's not going to work and you're going to need to know why. And so some expertise in AI, that's where that will help, and it will go, okay, so it's doing this. That means that we need to increase the learning rate, or that means we need to increase the amount of data we've got. Andrew Ng's machine learning course and similar courses are that starting point that gets you that AI knowledge, right? So knowledge on things like when you actually train, what actually happens, right? What happens to your loss as it goes down? And is it good that it's doing that? And how can we monitor this and make sure it's working correctly? There is a bit of maths, right? So if you're absolutely not okay with doing maths, then I would suggest a more practical kind of PyTorch course that just teaches you sort of the fundamentals of running the network without really obsessing too much about exactly how they're trained. Bearing in mind, you can always pick that up later, right? It might be easier in some sense to learn the mathematics behind a deep network after you've been training them for a year and you understand exactly how they work. So, there is that angle you could take as well.
I just think, even if you just dip into the course, it gives you kind of like terminology. You understand, like if we talk about supervised, unsupervised, we talk about transformers, at least you understand what that means. Because if you're totally new to this, it means nothing, right? Sorry, go on.
No, that's absolutely right. I think that learning the terminology and understanding a bit about what they are lets you work out what the best tool is for the job. as well, right? So for example, transformers, which you mentioned, are very common all over the research and industry actually. Most big models use a transformer in some way, mostly to do the text and the text to image and image to text. But actually, we've had tasks where the transformer doesn't work. Right? We run a transformer, it doesn't work. Not enough data. The problem is different. It doesn't work. But we have other things we can use as well, right? Because we know what they are. So I think understanding a bit about these different technologies will mean you apply the best one for the job. Because sometimes, these big models are overkill for what you need. Actually, you need to just detect something in some object, some image. Your image is very consistent. The same picture gets taken every day. Nothing changes. That's a few hundred images in a small network, and you've solved. Sometimes you don't want to overthink these things. More basic is better.
I just think we've got to the point. I've seen this shift in the last year where ChatGPT was like this catalyst where it became mainstream. But since that time, I've seen TikToks, I've seen Instagram videos, I've seen YouTube videos where it's totally AI generated. You can see it's an AI voice, it's an AI image. So this stuff's getting applied more and more in a lot of places. I think the days of like ignoring AI are over. You have to get involved at some point. Would you agree with that?
Yeah, no, I mean, I work in AI, so I'd love everyone to do that too, right?
But I think it's so general now, right?
It is. So, I mean, most people that are using AI that we see in the media and, on TikTok and social media and so on, most of them are just running it, right? They're running it without too much of a concern for how it works. I think you put yourself in a really strong position if you just know a little bit about how it works as well. And particularly because at some point, someone's going to present you with an image and say, this was AI or this wasn't AI. And isn't this amazing? And the hype stuff is going to start to come up and you can go, hang on a minute, I'm not sure about that. I don't think that was done in that way. And, I don't think that's quite as impressive as you think, or maybe it is. But I think, that understanding really, really helps. And so I think you don't need to be able to write your own transformer paper. I think just understanding a little bit about how they work and why they've been designed that way is a super useful thing to do. And then, you can get on the AI, you can get with the AI and you can start using it. Right? You can use these things as well.
I think for like someone who's like not technical perhaps, and I hate to break it up, but I see it like I mentioned in the beginning, like three groups: people who are perhaps not technical but can interact with an AI and learn how to leverage an AI just by talking to ChatGPT. But that's like the beginning, right? And then you want to go to the APIs and you want to use Python and understand it. And then the third is like going and actually understanding more and more. And the opportunities are in all three places, but you're going to be in a much better place, I think, if you're like in the second group where you're a programmer or someone interfacing with an API, or like in your position where you're actually doing much more with AI.
So there's three groups, right? So the first group is just people who've had a go at generating some images online. So they go on the website, there's a text box, you type in your prompt and an image comes out. And, you are controlling AI in some sense, but only in a loose sense, right? Yeah. And I suppose the interesting thing about that is there's a lot of stuff, you hear this term prompt engineering, which I think is a really interesting term.
The next job. Sorry, what did you say about it? Sorry.
Yeah, I said it's a really interesting term because in a way you're trying to control something that the people that train the network don't really understand it, right? In terms of what it will and do with certain prompts, which is so interesting. It's like you've got someone working for you, but they don't speak your language and you don't speak their language. You're just shouting words at them to hope that they do something that kind of works. I think that's really interesting. But of course, you run the risk that, if you build any kind of product based on something like that, you run the risk that the underlying network will be changed or the API will change in some way and suddenly it doesn't work anymore. Because when these networks are retrained, we can't guarantee that they will do the same thing the second time. Some understanding of how these networks work lets you, control for that a little bit, and you can be a bit more sure that what you do is going to be predictable. So perhaps the next level up would be someone who's, using the API and is perhaps doing something. So, for example, something that companies often do is they will prime a chatbot with some text that allows you to control exactly what it says. So let's imagine a hypothetical situation where I want to write a tech support, but I don't want to pay anyone to do tech support. So what I'm going to do is I'm going to write all the answers for tech support into the chatbot so it has that information and then let it do my tech support for me. Now, that might work quite well at first, right? Because as long as people ask simple questions that you've just given it the answers to, it will produce lovely answers for those things. But if they ask, what are your opinions on, this conflict that's going on across the world? Or what's your opinions on, really political hot topics, or what are the instructions for bomb making, it might tell you those things because those are still in the original training set, right? So you have to be quite careful if you're going to create a business that's based on hoping that one of these large language models will act exactly how you think. Right? So that's a really interesting problem that's not been solved yet, and we'll be seeing people hopefully addressing over the next few years. And then perhaps a little bit above that is, okay, so you've got some tasks you want to solve. A large language model or segment anything network will kind of work, but it's not good enough, right, for your task. That's when you probably need to train the network yourself. And then, that's going to be a case of you download the repository, you write your data loader so that your data's going in, you write your objectives so that it knows what to learn, and then off you go and wait. So I suppose there's different levels, but you can always start with one and move to the next one as you build up more expertise.
I've seen people, the example for the second group I've seen is someone who, and I'll link the video below, who uses AI and Python to, for instance, he says, go get this video off YouTube and then give me like a 10 bullet point summary of the video and tell me if it's how important it is that I watch it based on my preferences. And he's like put that all into a Python script.
So ultimately, that's not training a network or changing the configuration of a network or something like that. And you may find a time where your script doesn't work because something's changed in the video or the network that means that no longer functions. In a way, it's a bit like using any programming library. If they deprecate a feature and change it, you're going to have to change your code base to reflect those changes. Otherwise, your code won't work. And so it's kind of a similar deal, except perhaps that the pace of change is very, very rapid. So you might find that your prompts from this month don't work next month. And so, there's a bit of a risk there.
But if I want to go to like the third group, do I have to like buy GPUs or do I have to rent stuff in the cloud, or is it like a way to, actually do that? Just like to learn?
No. I think if you're a company and you're looking to do, proper training of AI, then cloud resources like Azure or AWS will have you covered, right? If you install your own local stuff, you have to obviously support that. You have to pay people to look after the machines and make sure they run. But on the other hand, ultimately, it's probably marginally cheaper, depending on how much training you're doing. The cost computations get quite complicated depending on, what you're up to. But of course, if you're just playing around with these things, trying to learn them, then something like Google Colab is perhaps the best place to go to. So Google Colab is what we call a Jupyter Notebook style interface. So essentially you have lots of text boxes where you can put in Python code, but it also has access to GPUs. It has all of the libraries basically installed already, so you don't have to do any of that. You can just say, use PyTorch or import PyTorch, and off it goes. And actually a lot of the big models like Detectron 2, which is a really good model for object detection, they come with a link to Colab on the Git repo so that you can click on it and just run it straight away and see how it works. And actually that's how I learned how Stable Diffusion works as well. When Stable Diffusion came out, I went on the GitHub, I went to the Colab, and I started playing around with the networks to see what they would do. And it's a really great way of learning.
And that's free or low cost, right?
It's very low cost. It's free for the sort of entry level. You'll just find that if you get overexcited and you use it a bit, you might have to wait for a GPU, right? So, you can pay, I want to say it's about £8 or £9 a month, British pounds, for a monthly access, which gets you pretty much, all the access to a GPU you could need, unless you're some sort of ridiculous power user. But, there are lots of tiered pricing models. But I think it's a good place to get started because you may end up not using Colab in the long term. You may have your own systems or you might use proper cloud compute. But I think for just running things and trying them out, it's a great place to go. I mean, that's where I wrote my demo. And I've actually written other demos as well in Colab because I know that when a student clicks on that, they're going to get access to the code they can run, which is, is reassuring.
So for everyone who's watching, once again, I've linked a video below where Mike actually demonstrates this stuff. I'm asking all the questions that I'm hoping a lot of you are thinking about. So I know the answers already, but that video is linked below. Great demo. So Mike, again, thanks for sharing that. Another question that always comes up is books. Do you have any recommended books or study resources apart from like going to the PyTorch and GitHub? And
I'm a big fan of any not too long introduction to Python and PyTorch, right? Yes, the problem is if you buy, so Yoshua Bengio and his colleagues wrote this incredible book called Deep Learning. Right? Now, by all means, get that book. I own a copy, but it's a big read, right? And there's a whole section on reinforcement learning. There's a whole section on supervised, and they'll be there for weeks. So if you need a really good reference for one specific area that you're looking to go into, then sure. Right? If you're looking to pick up PyTorch and run some stuff, then really what you need is a book that will get you there quicker. And I think that's something that teaches you Python, teaches you the fundamentals of how PyTorch works, things like data loaders, the training loop, right, which takes a bit of getting your head around the first time, and how it trains the network, things like this. That's the place to go. So there are a few books that we can link to that have, but are like not too high a barrier to entry, I think. And that's where I would start.
That's great. I'll link those books below. So if anyone wants to get them, I'll just be aware I'll use a Amazon affiliate link. So thanks if you want to support me, but I'll put those links below. Yeah, Mike, and thanks for sharing that, because it's, some people learn by doing, some people like watching videos, some people like reading. So this gives us a whole bunch of resources. Now, another question. You train or teach a lot of people at university, and a lot of them are perhaps beginners. So talk to people who are starting out or people who are changing careers. And it might be a bit of a nasty question, but like even advising yourself, what would you advise yourself to do in 2024 is like jump into AI as soon as you can, do computer science, or what would you advise if you're talking to your younger self?
I mean, I spend my entire life telling people to do computer science, and I will continue telling them that until either I retire or I die. One of the two things. I love telling people about computers, and AI is just one of the cool things you can do. You don't have to do AI, right? But for the sake of this video, you absolutely do have to do AI. And I think what I would say is, so actually, as an example, I recently took up the drums just for a bit of a laugh. I wanted to be good at the drums. And I was absolutely hopeless at them, but I kept doing it about an hour a day, and now I'm actually not bad, right? And I think actually it's similar with everything, right? Like with AI, I have students that come to me for, let's say, project work. So that's in the final year of university, where you basically do a sustained period of work and then you write up a large dissertation, right? Or, big essay, essentially. But you have to produce some software or something that works. And obviously I mostly supervise AI projects. And so these are students who are decent at, computer science, but maybe haven't done any AI before at all. And within a few weeks, they're training networks. And within a few months, they've got proper tools going, and it's really, really impressive. It isn't quite as much work as you think, right? Yes, becoming a sort of PhD expert will take you some number of years. But I think to get a baseline level of AI knowledge is only a few weeks and months, really. I'm also a big fan of learning by doing, but I do think that just clicking run on a Colab notebook isn't quite enough. You need to have a little bit of video intuition or a little bit of reading just to make sure you understand what's going on under the hood. But it's not, it's not as much work as you think.
I love that. It's really motivational because, people look at this, or I think a lot of people would look at this and think it's like a huge mountain. How many years of experience have you got? I mean, and all these, degrees and stuff, PhD, I can't do that. And I'm glad that you're saying it's not as difficult as that.
No, I think doing a PhD is a very different set of skills. So for example, one of the things that I can do quite well because I've had a lot of training is learn new things very, very quickly. So if a new paper comes along with a new kind of network, I can pick that up within an hour or so and know what's going on and what's good about it and what's not good about it. And that's useful for my job because that is basically what my job is, right? But actually, if you're working for industry, that's less of a concern perhaps. You want to be keeping an eye on what's coming along, but actually a lot of it is you've got some product to deliver and it's going to use AI. How do we go about doing that? And so there's a sort of set of steps that everyone's going to do in that situation. Learning those steps doesn't require that many years. It's just something that you start off, you get that baseline knowledge and then you can learn on the job.
So like you've been saying, and a lot of people say, start with Python. If you haven't learned Python already, you need to learn Python in 2024. Learn PyTorch. Go and look at Andrew's course on Coursera if you want to get like an understanding of AI. But if you just want to jump straight into it, PyTorch is a great way to get started. But you need Python as your beginner.
You absolutely need Python. PyTorch, so there are other libraries. You could use TensorFlow, for example. But my experience at the moment is that the sort of the momentum of the research community and industry is behind PyTorch as of today. Now, of course, we don't know what will happen a year from now. Some new fancy product comes along, we all get overexcited. But at the moment, PyTorch has got a huge number of repositories, a huge number of tutorials, huge amounts of help. If you read a paper that does something cool, like detects objects that you wanted to detect, there's chances are there's a GitHub repo that implements that paper and you can kind of run it. And in doing so, then learn how it works, right? And put yourself in that code and fiddle about with it and see what happens when you change some of the configuration. Yeah, what I would say is I think at the moment, because there's so much hype around AI, there's perhaps a tendency for people to leap into the shallow end of AI really, really quickly. So that is things like prompt engineering, just running models, look all this AI I can do. And that's a great place to start. But I would quickly advise people just try and get a little bit more of a feeling of what's going on underneath, because then you're better skilled when those things change and adapting to those things, right? And also, for what it's worth, I think it's a really fun place to work. There's a great community around AI. It moves very fast, but the core concepts don't move as quickly, right? So, supervised versus unsupervised learning is still the same as it was before, pretty much. And so, you can learn these topics and they'll keep you going for a good number of years while you can work on the other faster moving topics.
But I also think it's just money, right? I mean, a lot of people obviously want to get paid well for doing this, and jobs pay really well.
Yeah, they do. I mean, it's a constant complaint in academia because, all the best students, off they go, right? They pay really, really well. And obviously it depends on the job. Like, if you've sort of self-trained, you aren't going to be able to jump into a top AI job straight away. I mean, maybe, I guess, if you can really prove yourself, don't rule it out. But I suppose, but you can move up quickly, right? If you show your potential and you learn these techniques. If you obviously have a PhD, you've got a set of skills already there written down on paper, so it's perhaps a bit easier. But I don't think it's out of the question for anyone to do this, right? I think you just have to. It's just like any job. You don't start at the top managing. You start somewhere at the bottom, but you pick up the topics and you get better at it. And and they all pay pretty well.
I always advise people to ride the waves. I mean, you and I have been around the block a few times, and in tech, I've ridden quite a few waves, like voice over IP going back many, many years, opened a lot of doors. And then there's like in networking, there's automation, et cetera, et cetera. The point is, if someone's younger or someone's changing careers, jump on this wave, right?
There's no downside as far as I can tell, right? Because normally you might imagine there's a downside where, like, what if this technology goes kaput in, I'm learning some specific library. I'm going to pick a bad example, but let's say you're a JavaScript programmer and you want to learn React, right? Now, React's great, but it might not exist in 5 years' time, right? It might not. Let's not, this is not a prediction.
Now, I've got a really good example. I learned OpenFlow and that was hot for like a while and then it just died. Sorry, go on.
Exactly. You can't rule it out absolutely. With AI, I think we can kind of rule out the idea that it's going away.
Yeah.
Right? Because it just keeps getting better. And also, it solves so many problems. Even if it didn't get better, it's still super useful for solving problems as part of other pipelines and things like this. An understanding of AI that you get in 2024 is going to last you a lifetime, because I just can't see how it would go away. It will look very different in a few years, but you'll be able to build on that knowledge that you've already got. So I think there's no drawbacks.
I love that, because it's, like some technologies, it's a solution trying to find a problem. But like you've said here, there's so many problems already being solved by AI.
Outside of the core of the hype stuff that you see in the media, there are thousands of examples of smaller AI and deep learning applications that are solving problems across the world, right? And they just quietly happen behind the scenes. They don't, get all the big hype, but they're doing a huge transformative job. And so even if you don't go and work for the big tech company training the next ChatGPT, you might still be doing something with massive impact, right? And really, really worthwhile doing. I think that the roadmap, right, for AI is a smidgen of maths dotted throughout, right? But I'm not going to mention it. Is learn Python, learn PyTorch. You could use another library if you want, but I recommend PyTorch. Get a supervised model going. So supervise some learning, right? So get your data set. It doesn't matter what it is. It can be a public one that already exists. It can be something you went out and shot on your phone. It doesn't matter at all. And train a supervised model that solves that problem. And you're already a good chunk of the way there now, right? And then you can start making the problems a little bit more complicated, or you can move from a simple classification problem to maybe a segmentation problem or something like this. That's, I think, the right way forward. I wouldn't start with anything other than supervised learning, because it's the most intuitive, right? You give examples, you learn from those examples. And once you've done that, you also have seen all the PyTorch you really need for all the more complicated examples. They just have more code, right? That's the difference. It's still the same stuff.
Mike, I really want to thank you for sharing. As always, you separate the hype from like the reality and give people hope, because that's always one of the worries I hear from a lot of people is, like, if I'm 18, why would I bother even learning tech, going to do computer science, because AI is going to eat all my jobs? I really appreciate you, giving us hope with that.
It won't, right? And, particularly if you know about AI, right, there's always going to be a need for this. I think that Whether or not something will take someone's job is something for a government to worry about. I'm not particularly worried about it at the moment on behalf of everyone else, at all. I train AI. I'm hoping that I still have a job soon. We will see. If you keep inviting me back as an associate prof, we shall see. But I think that it's an exciting time. It is overwhelming, but actually there's a huge opportunity and it is really fun. So, you start training. There's nothing actually I find more satisfying than when you train that network and it actually does what you asked it to do. That's super cool when that happens. Even though it's ultimately just Python code you're running, when it actually works and you see that output, it is good.
And you don't actually understand how it's got there, right? Because you're just giving it data and you're teaching it.
No, you don't understand it's essentially a really complicated function that has done something clever. We sort of have a gist of we have an intuition as to what it's doing, but ultimately we don't really know what it does. But actually I've stopped worrying about that a little bit. If it works well, I'm kind of okay with it.
I love it.